Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 4 of International A-Level Edexcel Mechanics M1 January 2022 paper. So the question says that at time t is equal to 0, a small ball is projected vertically upwards from a point A, which is 24.5 meter above the ground. And then what happens is that the ball first comes to instantaneous rest at the point B, where AB is equals to 19.6 meter, and first hits the ground at time t is equals to capital T seconds. And then it says that the ball is modeled as a particle moving freely under gravity. Part A's requirement is to find the value of capital T. So what we are going to do over here, first of all, we are going to make the question easier for ourselves to comprehend. We are going to make a diagram. We are going to make a sketch. Okay, we are going to visualize this whole scenario. So what's happening is that a small ball is projected vertically upwards from a point A, and the point A is 24.5 meter above the ground. So let's say it is the ground, and here we have a point A which is 24.5 meter above the ground. So at point A, we have a small ball which is projected vertically upwards. The ball is projected vertically upwards, and the speed of the projection is unknown right now. The initial speed is unknown right now. And here we have the highest point of the ball from which the ball will return to the ground. And the ball first comes to instantaneous rest, means it comes to rest at that particular instant. Obviously, when the ball will reach the highest point, the velocity will become zero and ball will change the direction of motion. So at this point B, the ball will come to an instantaneous rest. And as we know that the distance between A and B is 19.6 meter. So the ball will come from point A to point B, and then the ball will return to the ground. And the information which we have been given over here is that the ball first hits the ground at time t is equals to capital T seconds. So this whole journey has a time duration of capital T seconds. All right, so the first and foremost thing is that we don't know the speed of the projection. We don't know speed of the ball at point A. So what we are going to do, we are going to consider the AB part of the journey. And first of all, we are going to find the initial speed. Initial speed is unknown to us. Okay, we are considering the journey from point A till point B. The displacement would be 19.6 meter. Since point B is 19.6 meter above the point A, and acceleration would be due to gravity, which will be minus 9.8 meter per second square. Okay, since in this journey AB, the velocity will be decreasing, the particle will slow down as it will go up. So acceleration is minus 9.8 meter per second square. Here we are talking about the vertical motion under the gravity. And obviously at the point B, the final velocity will become zero as the ball comes to instantaneous rest at that point. Okay, so the final velocity will be equal to zero. So what we are going to do, we are going to find the initial speed, the initial velocity of the ball. So V square is equals to U square plus 2AS, which means 0 square is equals to U square plus 2 times minus 9.8 times 19.6. So in this way, we are going to find the value of U. So U square will be equals to 2 times 9.8 times 19.6. So U square is equals to 384.16. Okay, and U will be equals to therefore under root of 384.16. Since we are talking about the speed of the projection, so obviously we are going to ignore the minus sign over here. That's why I've only taken under root of 384.16. Okay, so under root of 384.16, U will be equals to 19.6 meter per second. So u is equals to 19.6 meter per second is the speed of the projection. All right. So now what we are going to do, we are going to consider the whole journey in which the time duration is capital T. So let's say this point is X. All right. So now what we are doing, we are considering the journey of A till X. We are considering the journey from A till the point X, and here the initial speed is 19.6 meter per second, as we have already found, and acceleration would be minus 9.8 meter per second square, as we are considering the whole journey. In this whole journey, the velocity would be decreasing, and when the ball is going up, it is decelerating, and when the ball is coming down, it is having a negative acceleration, meaning it is having an acceleration in the opposite direction. So for the whole journey, acceleration would be minus 9.8 meter per second square. And as far as this journey AX is concerned, so the time duration is capital T seconds over here, and the displacement, since we know the fact that if we move from point A till B, the displacement will be 19.6. And if we come over here, let's say this point is C. So the displacement of A till C will become 0. And when we move towards point X, so when we are considering the journey of AX, the displacement would be minus 24.5 meter. All right, these are the basic concepts which you have already studied. So the displacement would be minus 24.5 meter. Since the particle is changing its direction of motion and it is going beyond its starting point. So therefore, the displacement would be minus 24.5 meter. And now we are going to solve this equation. So S is equals to ut plus half at square, and specifically for this part of the journey AX, the time duration is capital T, so we are going to use the capital T over here. So minus 24.5 is equals to 19.6 times capital T plus half into minus 9.8 multiplied by capital T square. So therefore we are going to solve this quadratic equation. So this would be minus 24.5 minus 19.6 times capital T plus 4.9 capital T square, and this whole thing is equal to 0. So the equation is 4.9 times capital T square minus 19.6 T minus 24.5 is equal to 0. So we are going to solve this quadratic equation. Capital T is equals to minus b plus minus under root of b square minus 4ac over 2a. So minus 19.6 plus minus under root of minus 19.6 whole squared minus 4 times 4.9 times minus 24.5, and this whole thing is divided by 2a. Whole thing is divided by 2 times 4.9. So t would be equals to 19.6 plus minus under root of 864.36 divided by 9.8. So 19.6 plus under root of 864.36 divided by 9.8. Here we have t is equals to 5. Okay, and the other value is 19.6 minus under root of 864.36 divided by 9.8. So the other value of t is minus 1. And since you know the fact that time cannot be negative, so t is equals to minus 1 will be rejected, it will be ignored. So therefore t is equals to 5 is your only acceptable answer. So here we have the answer of part A. Now in part B, it is asked to sketch a speed time graph for the motion of the ball from t is equals to 0 to t is equals to capital T seconds. No further calculations are obviously needed in order to draw this sketch. So here I'm going to erase the workings. of part A, and we are going to make a sketch over here. All right, and we need to make the speed time graph, not a velocity time graph. Okay, so you need to make a speed time graph, meaning you have the scalar quantity speed on the vertical axis, and on the horizontal axis you have the time t seconds. So from t is equals to 0 to t is equals to capital T seconds, and as we already know from part A, the value of capital T is 5 seconds. So we need to sketch a speed time graph for the motion of the ball from t is equals to 0 to t is equals to 5 seconds. And as you already know that from part A, we have calculated the speed of the projection, meaning the speed at the point A, meaning the initial speed. So it is 19.6 meter per second. So here we are going to make a line which is downward sloping, and acceleration is minus 9.8 over here. As in the initial part of the journey from A till B, the particle is decelerating, and then the particle is accelerating in the opposite direction. But since we are making a speed time graph, not a velocity time graph, so obviously we will make an upward sloping line from this point onwards, and make sure that the angles with the horizontal look the same. Okay, you don't need to make a much distinguished line, meaning you do not need to make a line with different angles from the horizontal. Okay, you need to make sure, because the absolute value of the gradients of these two straight lines will be obviously same, which is 9.8, and obviously the final speed by which the ball will hit the ground would be higher than 19.6. Okay, so anyone who sees this graph would be able to identify that when the journey is completed at the time duration capital T seconds, the final speed of the ball is higher than 19.6 meter per second, and no further calculations are required. Even if you do not mark this value of t over here, okay, so it's not an issue, it's completely fine. But if you have used an alternative way in part A, in which you have considered the journeys separately by finding the individual time durations, so you can mark the value of t. But in this case, no further calculations are required. All right, so no further calculations are needed over here, and here we have completed the sketch, and this is the part B. So this was the question number 4 of International A-Level Edexcel M1 January 2022 paper.